because you'll be killing a lot of animals, and we know some non-government organizations and advocates of protecting the animals. And thus, you can make use of simulation to do this. So in environmental chemistry, I teach QSPR or QSAR. What is QSAR and QSPR? It's actually a methodology wherein if you know the structure of a particular chemical, you can input it or encode it in a particular software that would generate the different physical and chemical parameters or properties of this particular chemical. So in this case, you don't need to, and then they just correlate these parameters in order to compute for the NOAEL or no observable adverse effect level. Now in this figure, you have here the different dosage or the different LD50 rather, of rats and mouse with different chemicals. Chemicals such as methyl, ethyl, ketone, pyrene, dieldrin, etc. But again, as I mentioned, they are already minimizing the utilization of this estimation technique of risk. Might as well do the simulation technique. Okay, there are factors, class, that affect toxicity of a chemical or material. What are these factors? As I mentioned, the number one factor would be the structure, because the structure or the form and innate chemical activity of a substance would determine whether it is highly toxic not only in humans but also in the environment. Of course, dosage would be another factor, the exposure route, the species itself. By the way, when you conduct a life cycle impact assessment, the requirement for you to identify the characterization factor of a certain chemical is that you must use at least 3 phyla. So 3 phyla that would absorb the chemical. So for example, one species of fish, one species of algae, and one species of a certain animal. Another factor would be ability to be absorbed, its metabolism, and its distribution within the body. So for example, if one gets contaminated with the same concentration of the same chemical, it would vary if another person will be contaminated of the same dose, of the same concentration, because the other person has a different weight. That's why for nutritionists, they compute for what they call BMI or the body mass index. So that's also true for chemicals or materials which are toxic. Of course, this would also be dependent on the excretion. So, for example, antibiotics are known to be 80% excreted from your body. So that means if you drink a 5 milligram antibiotic, only 20% of which is being utilized by your body. Then the rest, it will go to your feces or urine. And then of course, the interaction of these chemicals with other present chemicals. This study of toxicity is called epidemiology study. Now, there are difficulties of doing such a study because of the following reason. Number one is difficult to match the control group. So, for example, you have identified 3 phyla. You have to establish the correlation of these 3 different species. Number two, society has become mobile, so an individual which is under study can no longer live in the same community. Therefore, the acquisition of the toxic materials will now be difficult to assess. And then number 3, death certificates typically measure only the cause of death. They do not consider the health condition of the individual, which would also justify the toxicity level of what a person has inhaled that cause his death. And then other toxicity endpoints beside death might not be measured with use of death certificates. So it's not only death that would tell you whether the substance is toxic or not. This would include miscarriages, infertility, or even learning disorder, just like with the leg. Another would be the accurate exposure data. It's very difficult to obtain because, for example, you have 100 population of mouse or mice or rats that is living in Manila. That would be different if the 100 mice or 100 rats will be living in Alaska. Then, large populations are required for these studies, and as I mentioned, some animal advocates will be very furious about knowing that these clinical studies are being done. And then, many diseases can take years to develop. So, this would make epidemiology studies very difficult to establish. Okay. There are some questions, though, that you can ask during exposure assessment. So number one is, what are the important sources of chemicals? So if you would observe, the succeeding questions that I will be discussing with you is the same as the questions, are almost the same as the questions you might ask yourself in identifying the biogeochemical cycle of a substance. The next question would be, what are the pathways of and routes of exposure? What amount of the chemical are people exposed to? How often are people exposed to? How much uncertainty is associated with the estimates? And what segments of society or ecosystem are more at risk? So these questions might be utilized in hazard evaluation or hazard assessment.